Ready.
Okay, so I'm Patrick Lewis, and today's talk is going to be about domain-driven design. We're used to, as software engineers, to try to make things perfect, okay? To see things from above. We consider ourselves some sort of architect or creators. But what's more important here is to create software that does an important job. For someone, maybe, but an important job. So what's the best way to create such software? Maybe you could try to use some modeling tools to model the real world problems. That's maybe a way, but nobody knows. What we know is that we want to address real world issue with our software. That is what I want to talk about today, and that is what I talked before in one of my talk called What Programming and Computing Represent. Maybe you can remember this. So let's say, for example, we want to create a software that is a virtual library for books. How would I go about doing this? Maybe a naive approach would be to maybe make simple storage with name and PDF files. But who are we to say that this is the right way to do it? So normally we don't work in a vat, we don't work in a vacuum. There's usually already a ton of software related to a problem we try to tackle, a problem space we're part of, interrelated to it. So which part are we going to fill in it? Are we going to integrate with pre-existing software? Upgrade it? Are we going to coexist with multiple ones? Is it an add-on we're trying to make? So this sort of reasoning and questioning is what drives domain-driven design. Saying, I don't know about this topic and I want to know and be able to do my job properly. There are generally two views or two sets of eyes with which you can view any problem. The first one are the eyes of the engineer. Very narrow-minded, strict to the principles. They know the techniques that can be used to make software. We are the engineers. We know what we do. We know the practices, and we know how to make softwares, right? The other view is the one of the expert in whatever we want to solve. A person that could talk endlessly in great details about his vision and his knowledge. We all interacted with people like that. So what we really wish for is to integrate both sides, to reflect those deep details in our software, but we usually lose this connection with those experts. We take their talk as just talk. So there's this gap between what we show them in the code, the software components, and what they discuss with us. So we got to find a way to do this. There got to be a better way to interact with experts. Either we force them to understand software jargon, or we got to learn the actual issue we are solving and express it clearly in our code, so that from that point on, expert can give direct inputs to shape and choose which component should exist. And from our side, as software developer, we should still try and maintain clean code, use what we know how to do better. We should combine both perspectives. Instead of shifting between two sets of eyes, either the expert or the software developer, we should have a collaborative, creative effort between software experts and domain experts. So overall, the sound may be too good to be true. So how are we going to do this? It's difficult to start a conversation with an expert, to get information out of their mind. You can try to sit down, explain to them what a UML is, but that usually won't work. You can try doing meetings, but still, mostly it's not going to work. So there's a bunch of format that could be used to do brainstorming to get as much information as possible. So one of those formats is called event storming. It's a sort of free-for-all brainstorming session with sticky notes that you put on a board. But that's just one way. To start before that, you need to get the conversation going. We can't start from nothing. What we can usually do is ask questions about scenarios that need to be implemented. And then we have to listen carefully to the language that the experts use. Why is that? So language, in general, hides concepts. Language is the most important thing when trying to understand a problem. That's one reason why we shouldn't dismiss when experts talk. We should also pay attention to every single technical terms that they use. For us, it's too easy to say, okay, I understand it. Let's dumb down the language that the expert use, and then so that we can understand it and put it in the code. but we should use the exact same language that the experts use. For example, if we say book code and the programming, we should not do that. We should instead use ISBN. So iteratively, through discussion and brainstorming session, we'll get better ideas of the problem space we're tackling. Initially, we had a superficial concept of things, but with each and every word and every discussion, we could get a hint leading to more knowledge that we might have been missing. We need to pay attention to the meaning of the words themselves, especially technical ones. We need as many ideas as possible, as many brainstorm, getting to know experts personally, to not get stuck on a thing and then not be able to solve the problem. The best refactoring that have the greatest impact are the ones that are motivated by those sort of insights. So taking time to sit down with experts and understanding them. That should also create a sort of shared common knowledge and a team, a common language that everyone can talk. However, we can't keep exploring forever without a goal. We got to select the important stuff out of all the information we got and all the brainstorming. So how do we know what is important? Well, at first it should fulfill the requirements of the stakeholder, the business case we want to solve. Otherwise, there's no money. That's why we should map and distill the information in a model. We usually think of UML diagram when we think of a model, but we're not limited to this here. When we talk about a model, we meet something more abstract, the concept behind the UML diagram. A model is the representation, but not a perfect representation of a concept. It's an abstraction that serves a purpose. It's how we instantiate the case we want to do. It should suit a particular problem it tries to solve. A model is a tool. The model tries to reduce the gap between the reality that the expert knows and the code. But remember, the map is not the territory. So a model lives in a domain. A domain being the problem space we are tackling, the stuff that the expert is expert about, the sphere of knowledge or activity. With models, we distill the knowledge and assumption we have about that domain. We try to find the essence and put it in a form that makes it valuable and purposeful. A model without a purpose shouldn't exist. For example, in the book case, a model could be about the inventory of books we have. That's something we have to model somehow. So there are many ways to represent this, many ways to create models. So we have to choose between the ways we could do a model, choose between the ways we can make reality into a software. But which one is more useful? It's up to us. It's up to us to try to do it iteratively. A good method to choose a model would be to use something called behavior-driven development, BDD, where the expert himself or herself will write the test that the model should fulfill. So here are some good effective modeling techniques. Binding, You can go into them. I'm going to share them online later on. So with everything we've said, the culmination of the domain, the model, and the exploration with the domain experts gives rise to a common language, a language that is used everywhere. This is the language that closes the gap between the software developers, teammates, and the experts. It's shown everywhere, so that the language the experts use is in the code, so the experts can open the code and understand what each component does. But that brings us to a question. Ubiquitous language within what? Teams are usually separated by projects, right? So the language and thus the domain and its model should be limited by something bounded, a context. So to be effective, models need to be unified so that there's no contradictions between them. We need to use the language that we've created with the help of our domain experts and create boundaries inside the domain space. Each context should have a unified, bounded concept, something it solves. So we do that by assembling multiple models together. We shop around multiple models, and then we find the relationships between them and create some sort of categories and group them in the context. So this makes sense here, this makes sense there. we could have, for example, a context related to shipping books and another context related to manufacturing books. So the language we use should show where the boundaries are. For example, if two things have the same name but mean different things, then they should probably be in different context. Or the opposite, let's say two things have this different name but they mean the same thing, so probably they're in the same context and the same entity. So again, the question about exploring with domain expert is the way to go. One such division is about core domain. So let's say they are separation between what's important for the business. We call that the core domain. We could also do separation between what's generically used between multiple contexts. But let's skip here. One key aspect of the bounded context in general is that it also defines the relationship between teams and organizations, because every teams have a different language. And because they work on different concepts. So the shape of the organization is directly reflected in the way the contexts are made. So we should be explicit about the relationship between those bounded contexts. So different contexts still need to interface with one another. Let's say there's a common library between two teams, especially in this case. So there's many ways to do this, to interface between contexts. One of them is the shared kernel, like having a shared library. So in this bounded context, they use the same name for the same things. Let's say they have a common conception of what is a customer. Okay. Or let's say they could have a customer-supplier relationship. One of them demands something, the other replies. Or conformist, following a fixed set of rules. Or they could go separate ways, working completely separated. Or anti-corruption. One of them works and the other tries to create a layer in the middle so that his own code is not tainted by the language of the other one. So they can translate what a word means for the other and the word and the names that means inside his own context. So because we are developers, software developers, we want to memorize things and apply them into the code. So in DDD, it's not really mandatory, but people invented such concepts to help them map the way domain experts talk about context and names and language inside the code. And it's helpful because when we write libraries, we can use this knowledge. So an entity is an object with an identity, something that is not only defined by its attribute, but also by its functionality within a system. A good rule of thumb is that if it makes mistake, a good rule of thumb is that if you make mistake about the identity of an entity, then it's probably an entity. A value object is the opposite. It's a container of attribute, a bag of attribute. It's an immutable thing. Let's say it could be some colors, blue, yellow. But again, maybe in some context, blue and yellow are an entity that you should not mix with something else. Aggregates are like bounded together by a root entity. And then it creates a cluster of objects that are treated as a single entity of data. So the other ones I can go in depth later on. So the takeaway for this talk, let's conclude. Most software complexity lies in understanding the domain itself, the domain we're tackling. That complexity is the inherent one that stands against the accidental one. This is why we need to cultivate models based on the language of experts. This is what DDD teaches us, domain-driven development. No matter how much you do solid, high-quality, modular things, if we don't tackle the essential complexity of our domain, we won't be solving anything. This is all extremely important in today's world, as software gets entangled with everything in our lives, every part of our lives. So this is it. Thank you for listening.
Thank you, Patrick.
Thanks.
This is really interesting. Yeah, okay.
That's good.
There are some parts I skipped over. But I think the gist of the subject is here, what domain-driven development is, domain-driven design is about, how much you need to understand the language of experts. And it's really not about the technical part, but how to have the patience to model things.
Yeah.
Okay,
I
so
really
if you
liked
have
it.
any questions.
Yeah,
I really
questions.
Yeah, no, I'll just give as feedback that I really liked it. Like I did not read the whole book as far as I recall about a year ago, and I forgot some parts of it already for sure, and was definitely good repetition to get the main concepts again and how it works. So it was very helpful for me.
Okay, maybe instead of questions, you can recount the time where you were started working on a software, and it was something, a domain you didn't know, you thought you knew, and then you didn't ask an expert, started implementing something, and then suddenly you realize that you messed up, you misunderstood something, or similar stories.
I'll actually share something. It's actually funny. Few years back, we started a pipe manufacturing project. And what I wanted to add here was when we got the domain experts, our joint venture partners, they're Japanese. And literally every expert is Japanese and cannot speak English. So add that difficulty and complexity to the equation, and you can see how difficult it was to grab all the information from these people. We had a translator that eventually was hired by our partners, and they trained him in the domain so he can properly share information, because everything was taking so much more time than it should, because it was very difficult to grab information from them. But in the end, we did end up with modeling scenarios more than anything else, and literally all our lingo was about scenarios. What scenario does this fall on, and what scenario does that fall on? But it was incredibly funny how it started, but eventually it became much better.
Yeah. Did you use BDD, behavior-driven development?
We
like
started,
they wrote
yes.
the scenario, then you had
Yes.
to fulfill them. Yeah.
Yes.
Nice.
We started it's every time you start with such exercises, you start it out to be incredibly pure and nice and well done, and you follow it to the letter, and everything is great, until such a time where somebody loses interest. Just any person to lose interest, and the entire thing goes dominoes, and then you end up as the developer having to even maintain the entire behaviors himself, the scenarios and the steps and literally everything. It became horrible in the end.
What about knowledge sharing? Like, it's important, like, let's say somebody left the team. How do you retrain someone in this domain of expertise? Like, it's somebody not a developer is supposed to know about.
We had an entire knowledge base that was driven by Wiki, but that's pretty much about it.
So
Ephemeral.
I have a meta question to this. When you start those conversations, and I can totally relate also, like Omar, to many situations where you think that you are collecting requirements, you think that you understand the business, and then you start talking to experts, and then it's a different kind of conversation. So how do you capture this kind of expertise when you talk to experts?
This is the issue.
I know that BDD is one way, but like Omar said, someone needs to maintain it. You need a champion, and once this champion loses interest or has something else on his hands or her hands, then no one is left but the developer or developers. And that's not usually something that they can maintain. So how do you capture this complexity? What are the systems that you use to capture those complexities?
So actually,
and pass them on to developers or any other stakeholders? Yeah, that's done.
Yeah, sure. So in the book itself about domain-driven design, he doesn't address this. He doesn't say how to actually do this. It was left open for the community to try to find a way to to create a format that would be useful to gather the information, to do a sort of brainstorm with experts, and then summarize it, distill it so that you can use it actually in your code and map it to components in a way that you can also show, like let's say a UML. Even though an expert doesn't know what a UML is, they can still see it and know, oh yeah, I know what that is, that represents this. So one of those things, yeah, like I said in the talk, meetings are usually bad. They could work possibly, but it takes, like, let's say for a whole week, every day, 2 hours meeting, trying to find information from somebody who knows nothing about software, and you keep repeatedly asking them the same questions because you don't get it.
Yeah.
So one of those things was called event storming. It's like a one-day session where everybody just write on sticky notes and you brainstorm like hell, you stick it on a board, and then at the end of the day you say, okay, from all this board, you ask the domain expert, from all this board, what are the most important sticky notes? Then you remove all the rest, then you repeat it 2-3 times, and then you have to map it somehow to a wiki or something that you can share to create a common language between everybody and the team. But yeah, this is the issue. You have to keep the knowledge around, otherwise you're done. Your project is dead when everybody leaves.
I agree. I also haven't been across a system that actually does the work properly. Documentation is usually you capture the knowledge at a point in time, and then you need to continuously maintain it so it doesn't go it doesn't go out of date, and other things replace it. And also it depends on the person. Sure. In my experience, it depends on the person who's capturing the knowledge. Sometimes they understand things and they put them down in writing. They contribute to capturing this knowledge, but it turns out that when the experts look at it again, they might add to it. So it's a collaborative kind of work. So I haven't.
Yeah, it never ends.
Yeah,
never ends.
Okay.
Yeah, it's iterative. It doesn't end. So yeah, the thing is, when you distill the model, it shouldn't die necessarily. I mean, usually a domain of expertise outside of software. I mean, the mapping between the domain of expertise and the software is going to die really fast. It's going to change a lot every day. But the words of the experts, the knowledge itself won't die. Like, let's say it's storing books. Okay, yeah. Storing books is still storing books. Or containers. Containers are containers. Shipping. Okay, shipping is shipping.
Yeah.
But okay, how do you map shipping to the software? Okay, maybe we had a relationship with a database. Now we're using this or that. Okay, this changes a lot.
Yeah.
Yeah.
I have a theory related to, not a theory, something that I've learned is that you can definitely capture a certain level of business logic in the code itself through testing suite around the code, how it behaves.
Yeah, that's what Omar said, BDD. Yeah. Behavior-driven development is a way like the expert writes the code, the scenario, and in a textual way. Like he said, when this thing, whatever it is, this entity does this should happen, this event should happen. And then however you model it, it should still stay true.
Yeah.
But consistent. Like he said, if nobody maintains it for a long time, it goes to waste.
No, so if things fall down on developers, and if they write code in a certain way that clarifies the behavior, for instance, following style guides and a certain agreement within the developers, then you can preserve some of the logic. Of course, this is debatable. It's how do I say that? Like a shot in the ocean kind of thing. It might work. It might not actually work, but yeah, I've seen it working to a certain extent. All right. Any more questions?
It's investment in the end.
Yes.
Where you put your money.
Yeah.
Yeah. Any more questions?
I can shamelessly give an example on this. If someone wants to have a look at Tilt, it's our MENAdevs.com platform or code that runs MENAdevs.com. I've added some tests over there. There are behavioral tests like functional tests, and there are unit tests. And they kind of describe how the flow of information should happen. So that's more of where I was heading towards myself. So that's more of an example of what I was talking about.
Yeah,